G'day, just a quick update on the progress I've made on my Assistive Text Capacitive Touch voice module. I need to find a really nice name for that, but that's where it's at the moment. So I've had some success, which is great. It functions. I touch a button, it outputs an LED at the moment, but I also have some problems that when I touch buttons that aren't connected, they're also triggering the LED. So there's some issues with sensitivity that I've done a little bit of hacking of the board. I've done some grinding, which you'll see in the upcoming video, to remove ground planes and change things after re-reviewing the data sheets. And I've ordered my second set of boards, so hopefully I'll have them soon and be able to build them up, and hopefully that will overcome these problems. So sit back, see what we've done, an explanation of the circuit, and watch me butcher a board. So what this is meant to do is have 14 capacitive touch buttons that in theory will be on the inside of this case, and when we hit it from the underside of it, it will detect through it. And it is sort of doing that, but I'm getting false triggers. So button 1, which is there, I'm also detecting at times with button 5, sometimes button 6, not at the moment. And these larger buttons, when I enable them, are not working at all. So going back to actually reading the data sheet, which is an amazing concept to do, I've realized that these rings, which are my shields for active shielding, should not be a closed circle. So I'm going to have to go through and cut each one of them. So we'll try that to start with. That may be enough to fix it. You can see my track is routing directly underneath button 5. And that's more than likely causing some of the problems. And the third thing that I have read is my ground plane here should not actually be under my button. It should just be around it, both top and bottom. So I'm probably going to do a complete board redesign, but initially I'm just going to do some grinding to So after going through and grinding each of these rings so they're only a half a circle, or not quite a joint circle, I ground out one earth plane only just for testing. And I also found I had some dry joints on this surface mount chip that I'd hand soldered on. So I went through and did all of them. I didn't mention this before, but I had previously disabled the shield, which is this ring, for experimenting by opening this jumper. You can see that one there is still open. So basically I've re-bridged that one but left that one open. So what I can now do, I'll just slide it inside a bag so that we don't get the finger actually touching the board. So if I touch input 1, I get a response. You can't quite see that. I'll just slide everything up. So input 1 works. And it should not work if I touch anything else. So I'll jump up to one of the bigger ones. So input 3 is one of my bigger pads. So that's this one here. So we're looking at this pad just here. So that works when I touch it. Now there is a bit of a problem that if I touch near the other, I think because the pad is so big, I'm getting detection still. But I don't seem to be getting that through board detection that I was before. So we'll go up to 4. So pad number 4 is over here. I can touch 7 above it, I get nothing. 6, 5, 4, and touch any of the others, but as soon as I touch that. So basically we've improved the result quite dramatically by opening those circuits. Fixing up some dry joints improved it, but I will go through and reprint a board without that ground plane, but initially I'm just going to grind all of these out for proper testing inside of my case, and then I'll go about redesigning the board, relayering the tracks so that they're not so close, and see if we can improve on that. So the way the circuit is meant to work is we have these MTCH108 chips from Microchip, and they're basically a capacitive touch sensor. And we've got here several inputs, so there's 7 inputs even though it's labelled 8, because we lose one of them due to this guard function, which will basically allow us to reduce false triggers and also reduce moisture triggering it off. So each one of these, once they're triggered, gives us an output on the corresponding pin, which just gives us effectively a low going output once it's triggered. To turn on and off this guard signal, we have these resistors here. They're not really resistors, they're just spaces that I can short out on the board. So when they're shorted to ground, it does enable it, and when they're open circuit, it does not have an active guard. So the active guard is this outer ring here, which you can see as I highlight it, comes around and down into my chip somewhere down here. And so there's 2 chips and 2 separate rings of active guard, and the center pins are at touch. So basically that circuit is duplicated twice, so I have 14 outputs, and the only other additional I've got on here is my input going through a 3.3 volt regulator. I've also got the facility for battery on here, which is charged via this circuitry. But yeah, the heart of it is this chip here.